Hello, Melody. It's been a little while since we've last had you on here. Remind everyone exactly how old you are.
I am 12 years old. I am in 8th grade now after the summer. And yeah.
Cool. Well, it's really good to have you back on here again with us. And I've got a motto. And the motto goes, you can't judge the only cake on the table without another cake.
What does that mean?
All right. So the only cake on the table is the best cake on the table.
Oh, yeah.
Okay. The only cake on the table is the best cake on the table. If you want to criticize that cake on the table, you better bring in a different cake and say, okay, now we got something to compare, right?
Yeah.
Yeah. So that's my philosophy. And I like to criticize different textbooks out there, right? And so what does that mean?
That means you gotta have more than one textbook?
That means I got to bring my own cake. And
Yeah.
so I got to bring my own cake. And so I'm actually writing my own textbook. Okay? I'm writing my own textbook. And today I want to hear what you think about it.
Okay.
Tell everyone about it. And so this is the cover. And I want you to go ahead and I want you to practice reading it, because one of the things about my textbook is I want it to cover advanced material, but I want it to be simple enough for a child to understand.
Okay.
And so I want you to kind of tell me what you think about it, see how it flows off the tongue, and see how well you understand it.
Okay.
Cool. So here's page 1. Page 1. What is science? Go ahead and read that for us.
What is science? Most words in the English dictionary have multiple definitions, and the word science is no exception to that. With that being so, exactly what qualifies as science has been a thing of controversy.
Controversy.
So what does that mean?
Controversy means a highly debated topic.
Okay.
Something that is
Sounds
argued
good.
over a lot.
Okay. Over the years, with some people claiming one subject to be science and another subject to be pseudoscience or false science. To deem something as pseudoscience is a form of attack to try and dissuade people from believing in a given subject, often for personal or political reasons. However, it is important to keep in mind that the key word in each of the different definitions of science is knowledge, and people can have incorrect knowledge concerning things. Therefore, even if something is wrong, it can still be considered science. While science is not defined as truth, the practice of science can be described as the effort to gain experience and familiarize oneself with truth, or rather can be described as the pursuit of truth. Scientists, whether paid or unpaid, are seekers of truth. Like,
What did you think of that so far?
what do you mean? Like, what part? Do you think it was like...
Was it understandable? I used some big language there. Political. Do you know what political means?
Think?
Political means stuff that has to do with the government. A lot of things that you might vote on.
Mm-hmm.
What are your thoughts about the idea of science being something that's not true?
The idea of science that isn't true?
Something can still be considered science even if it's not true.
Oh. Trying to think about that because it's sort of confusing. Like, what do you mean by that though? Like, if they do a science experiment and it happens with a science chemical reaction, and it's still like, if they explain it wrong, or what do you mean?
I remember a long time ago in history, we studied the William Harvey. William Harvey, that was in the K-12 program, and about how William Harvey discovered that the heart was a pump. And all of the scientists before him all did not believe that the heart was a pump. They just thought your blood just sat there in your body. It wasn't circulating or anything like that. And so,
Wouldn't you get like blood clots or something?
yeah, it was a weird time. A lot of people had different notions and beliefs
Wait.
about blood.
So if blood was like that, what did they expect when you got a cut and
It was
started
just
bleeding?
falling out. It was just falling
Did you
out.
get it back?
That was something that we learned about in your elementary class doing the K-12 program.
Really?
Yeah, William Harvey. And that was one that always stuck out to me really strongly.
Wait, so it wasn't long ago when they believed that it started to pump?
I think it was in the 1800s. I don't remember the exact
so that
date.
is long ago.
Okay.
William Harvey. For a long, long time, everyone knew that your body was made up of 4 fluids called humors: blood, phlegm, yellow bile, and black bile. People thought of these fluids the same way some people today think about genetics, a handy explanation for like everything. So, say you had a bad temper, that meant you had tons of yellow bile inside. But if you were all detached and unemotional, your body was probably full of phlegm. Galen grabbed this idea and ran with it, coming up with lots of medical treatments, mostly involving cutting people open and letting their blood drain out. His medical books were so popular, they rocked the bestseller list for the next 1,500 years. And that's when William Harvey steps in. We've gone past the Dark Ages, the Middle Ages, and the Renaissance, but the medical world is still all about Galen. Harvey's a young hotshot doctor to British royalty, who's got it made if he plays his cards right. There's only one problem: he's way too curious. Galen was smart, but limited. For one thing, he never got to test his theories because cutting dead people open was a big no-no back in the day. It pretty much killed your chances of getting into heaven, so Galen had to figure things out either by guessing or by dissecting dead animals, which was kinda but not totally useful when talking about humans. But Harvey's got no qualms with slicing up dead people, even though surgery is considered a pretty trashy career move and done only by low-class barbers. He's inspired by a couple of Renaissance doctors named Vesalius and Fabricius, who are revolutionizing the world of medicine, but they've got way too big a man crush on Galen to really challenge his ideas in a major way. Not so with Harvey, whose curiosity leads him to ask more and more questions every time he digs into those corpses. Galen claimed that blood was produced in the liver and then sent up to different parts of the body, which used it up. Harvey says that makes no sense. Blood travels in a circle from the heart, through the arteries, into the veins, and then back into the heart.
Yeah, William Harvey. And so even though they had incorrect information, they were still putting the puzzle pieces together. And eventually, William Harvey was the one who discovered, oh, look at that. The heart is a pump circulating your blood and all this other stuff, right? Mm-hmm. So just because they had incorrect information doesn't mean it never got corrected in the future. Does that make sense?
Yeah.
And so it's just knowledge is the key thing here. And you can have incorrect knowledge, but you're still trying to put the pieces together and get a more correct knowledge. Does that make sense?
Yeah, so if you only found 5 sentences in a big paragraph and you put them together and thought that the cat was blue because you read those 5 words, it says so, but it's not true.
Mm-hmm. Yeah, there's a lot of big things there, but this is one of those huge. This is a very controversial topic right here as to exactly what is science. A lot of people will argue about that night and day. Right? Now let's go ahead and read this. Consider this.
Okay, consider this. In college, a person can earn a degree of science in various fields such as political science, the humanities, history, and art. Knowing the definitions of science, why would those fields of study be considered science? And then it shows the definition.
For science is, yeah. Art.
Why would those fields of study considered be in history. No, was it history? Maybe. Yeah, it was history. Or no, it was art. It was art. Yeah, they were actually talking about this exact thing.
Really?
Yeah, and
Yeah?
they're saying there's actually a lot of science in art. I just can't remember what they were saying, but I remember them bringing it
Okay.
up.
Okay. I can think of a couple different ways science is very much applied in art, such as when it comes to, there's some chemistry involved in ceramics, when you've got to get your clay at just the right baking point and being able to get the glazes just right. There's a lot of chemistry in the glaze work when it comes to doing ceramics, or even just mixing your paint and things like that. However, it's not quite it. That's not
Yeah.
everything there. Okay, so this whole focus here is on we've got our different definitions. Systematic knowledge of the physical or material world gained through observation and experimentation. Okay,
Yeah.
so it's just systematic just means organized. Okay? Organized knowledge. And so when it comes to art, there's a science in it when it comes to studying maybe how one artist takes an idea and it's called iconography. Okay? Iconography is very much a science where you have one character or an idea and then you watch other people copy that same symbol or idea over and over again in different places. And so one of the really famous ones,
The one with the swirly, like, sky.
Van Gogh.
Yeah.
Van Gogh is a very influential artist, and a lot of people, because he's so influential, they copy him. That's what makes him influential.
I've seen a Batman one before.
The Batman version of Starry Night. Yeah, that's a really good example. Okay, so systematized knowledge. This is page
Okay.
2.
Systematized knowledge. Imagine going to a library where all the books are scattered all over the place in random order, making it very difficult for anyone to find something they were looking for. How useful would that library be? How information is organized makes a difference. Wisdom, from Charles Spurgeon, right?
Charles Spurgeon, that's
Okay.
his name.
Charles Spurgeon. Wisdom is the right use of knowledge. To know is not to be wise. Many men know a great deal and are all the greater fools for it. There's no fool so great a fool as a knowing fool. But to know how to use knowledge is to have wisdom. Wisdom isn't just having information. It is knowing how to use it. A system is a way of organizing information. For example, you might have heard of Dewey Decimal System. I can't talk. That libraries often use when it comes to organizing books. Organization helps us recognize patterns in information, which in turning helps us to see the bigger picture and recognize ways to put the information to use.
How is that? There's a few things that you had a hard time. That didn't quite flow off the tongue as well as we'd hoped, but does it put the picture in your mind? Are you able to clearly understand it? Anything you don't understand about it?
I get that one and I get that one. I don't get that one though.
Okay, the third one. Wisdom isn't just having information. It is knowing how to use it. A system is a way of organizing information. For example, you might have heard of the Dewey Decimal System that libraries often use when it comes to organizing books. You might be right. I might need a comma. Organization helps us to recognize patterns in information, which in turn helps us to see the bigger picture and recognize ways to put the information to use. So,
Okay.
The difference between knowledge and wisdom here, okay? You can have all this information up here, but if you don't know how to use it, it fails. That's where you have the disconnect from wisdom. And so that's why it's so important to organize knowledge so we can easily access it and just think about the whole puzzle box that is not put together yet, right? Mm-hmm. And so it's chaotic. You don't see the big picture. But the moment you put the puzzle pieces together, now I see the big picture. And that's the difference between knowledge and wisdom. Knowledge is just having a whole bunch of chaotic puzzle pieces all over the place. Wisdom is actually putting the puzzle pieces together and seeing the big picture.
Okay.
I think that makes sense. Does that make sense?
Yeah.
Okay, good. This is so good for me to be able to just go over this because I can write this stuff in there if I need to.
Yeah.
Okay. So here's, I think, it's page 3.
Okay. Strong foundations. The wise man built his house upon a rock, from Matthew 7:24. The Bible uses the imagery of a wise man building his house upon a rock as compares to sand as a symbol of strength and sureness. Sureness. A faulty foundation is one that crumbles and falls apart. The sturdy foundation is a symbol of truth. While people's knowledge concerning things is not always right, the goal is to make our foundations as strong as possible, striving to understand the best of our ability. We can do this by building on a foundation of axioms, self-evident truths that require no proof. These are basic, plain, and observable facts, like how many fingers you have on your hand.
Is that clear?
Yeah.
Cool. Yeah. Building a strong foundation is building on axioms. It's a word that is really popular, I'm finding. I'm noticing it in more and more places. The moment you start to recognize the word, it's everywhere. It's weird. But I first learned this word from Alexander Gleason. I was reading his book, and he used the word axioms. And
I recognize that name.
He's really famous for his flat Earth map, the Gleason map.
Oh, okay. I was like, wait a second.
He wrote this great big thick book that is really hard to chew on. And one of the very first things he talked about in his book was axioms. And I just really liked that. It was very influential for me. Okay, so let's talk about academic pitfalls.
Okay. Academic pitfalls. The opposite of building on a strong foundation is building on a pitfall, a lightly covered hole in the ground that is used for catching people or animals. People walk on them, thinking that they are solid ground, and then fall through when covering is...
Sorry.
Huh? Oh.
Okay, so people walk on them, thinking they are on solid ground, and then fall through when the covering is unable to support their weight.
Okay. Academic pitfalls are claims that have no observations to back them up. If someone makes a claim like the sun is on average 93 million miles away and provides nothing to back up the claim, that qualifies as an academic pitfall because the claim lacks a foundation. It is important to remember that math formulas can also qualify as academic pitfalls. Math formulas require observations to verify them and show that they accurately describe reality. Just because the math looks right, 2 times 2 equals 4, a person can't just slap that on any claim they want and act like it proves something. Be in the habit of continually checking the ground you walk on by asking, what is that claim founded on? What makes you think that? And how do you know that is true?
So I've got an example here. Just because 2 times 2 equals 4, that doesn't mean a yardstick is 4 feet long. That goes over a lot of people's heads. And they're like, what in the world are you talking about? Did this help at all in just saying you can't just slap 2 times 2 equals 4 on any old claim you want and say that proves something?
Yeah.
Are you kind of getting the idea that I'm talking about here?
Yeah, because Oh yeah, like if they're saying how hot is the sun, and you're like, okay, so I know everything. I know math and everything. So the perfect equation for knowing how hot the sun is, first you measure like the diameter of the sun times 2400, and then you minus off the heat of the sun, and the equator equals like the heat. Like,
Yeah,
you're
it's just
standing there
you got this
like-
big. You can have this big, long, extensive formula.
then you stand there like,
People get math blind.
and then you're like, who measured the sun?
yeah.
And you're just like, yeah.
People literally go math blind and say, "Oh, that looks fancy. It must be right."
Yes.
Right? The appeal to complexity. That's what it's called.
Exactly.
Yeah. This is something that has been my biggest criticism throughout so many different textbooks that I've read over the years. And so that's something that I really strive to do with this book. Doing it different is really do everything I can to avoid any kind of academic pitfalls. And one of the really cool things about this book is how many textbooks do you have contact the author if there's something you have to say. You don't like the way this is written? Here's a way to contact the author and talk about it.
It's like trying to email the rice milk number on the container if it's moldy or something.
You can do that sometimes, right? Or at least go take it back to the store and say, "Hey, what's up?"
I've tried to prank call a rice milk.
Oh, really? You actually did that?
I tried.
Okay.
It always just sends me to like that robot person.
Oh,
Yeah.
of course they did. Okay, so this goes right in hand with the whole 2 times 2 equals 4 thing and backing up your claims. This one is scientific models.
Scientific models. In art, people often refer to the person being painted as a model. But in science, your model is what you have on canvas. It is your painting itself. A scientific model is a description of something. These descriptions can take various forms such as drawings, calculations, or even just words alone. The accuracy of the model depends on how well it describes something. With that, it is important to acknowledge the math itself isn't a foundation stone, but rather, math is a model that describes things. If someone were to say, 2 times 2 equals 4, therefore a yardstick is 4 feet long, that model would be an inaccurate way of describing a yardstick, since yardsticks are 3 feet long. Just like painting, math is something that needs to be verified by comparing it with reality.
So with this, kind of going back with William Harvey found a better way to describe the way blood works in your body, the heart.
Yeah.
But the guy before him, Galen, I think that was his name, Galen, he did not describe the body very well. So we can kind of describe this in art terms where like one person is doing like stick figures of a body and another person is doing a much more detailed picture. And so I think it's really important to kind of keep that in mind, that science and art here, that's a direct description. It's just observing reality, observing the world around us. That's kind of right in there in earth science. Do you have any other thoughts on that?
I think you explained it pretty well.
Okay.
Earth science. Earth science is a broad field of study that covers multiple subjects. In colleges and universities, you typically don't see specific classes referred to as earth science, but instead, you'll find individual classes focusing on the individual subcategories of earth science. Nonetheless, each of these subcategories affect each other, wherein it is important to take the time to observe the big picture.
What do you think of the little conspiracy board? It's just starting there in the top.
Yeah, I think it's cool and it helps you see that they're not all just their own thing. They're connected to the bigger thing, earth science, like astronomy, geology, oceanography, and then meteorology.
Yeah. The big deal is about seeing the bigger picture here. We keep talking about this, putting puzzle pieces together. And I like this nod to making conspiracy boards, which are there to help people see the big picture.
Yeah.
I feel like way too often people get too compartmentalized, and especially in college, all they do is focus on one aspect of things. And if all you're focusing on is astronomy, then you end up forgetting things about geology, and that ends up changing your view of things, and vice versa. So there's a lot of overlapping principles that apply, how one thing can very much affect another thing.
Yeah.
Any other thoughts on that?
No, really?
Okay, we can go on.
Why it matters. Earth science is a highly controversial topic. It is a big deal in both politics and religion. Did the biblical flood actually happen? Is the world currently in a state of climate crisis? Has man actually been to the moon? Those are all earth science questions. World governments spend extreme amounts of money in departments related to earth science. According to Space.com, NASA's budget for the year 2025 alone was $25.4 billion. With so much money, it becomes a really big deal as to whether they're telling the truth or not. The more you know, the harder it is to deceive you. Knowledge is your weapon against lies.
Okay. I really like the way this picture looks. And for me, this really emphasizes what really got me interested in earth science. When I was going to college and even in high school, I just looked and said rocks and gravel. I didn't really see the big picture yet.
Yeah.
I didn't see how important it was. And the way textbooks even write, why is this important? Well, you just might be digging a well someday, and this might be important for finding oil or rare minerals or something like that. Mm-hmm. If you have a job in mining, it's going to be important for you to know. Okay, well, I don't really want to be a miner.
That's why I fell out of school.
So why is this important to me is the question. And so the way this is written out, it's about how earth science isn't just for people who want to look for fossils or something like that, you know what I mean? Or find water. It's not specifically there for people who are looking for a career in earth science, but it
helps open it up to like everybody, so then they don't just have to work on it or be an astronaut when they're older or whatever they want to do, but like it helps them see what things are actually going for and like what's actually happening. And
it's a pretty big deal when you really get into it. Just kind of looking at just NASA's money here. We talked about the budget, but when it comes to religion, it's like huge. Kind of the whole matter of the fight is real between religion and the government, and trying to the atheist agenda and all that kind of going in there. There's a very real agenda there to fight it in our public schools. And I feel like when we study earth science, our eyes become very open to it, and we can see it. Any other thoughts?
It's just crazy how much money they spend, and like, just want to know what they're actually using it for.
Yeah, what are they actually using it for?
And it'd be cool to like measure how much money like each person actually spends, like just in tax and stuff, like every time they have to spend money.
Yeah, I mean, interesting to do an audit sometime to see exactly where all of the money goes. I've heard of NASA spending tons and tons of money on coffee cups before.
Coffee cups?
Yeah.
For what?
That was it. It just said coffee cups. And yeah, they're spending like $100,000 on coffee cups. And it was weird.
It's like, congratulations for working at NASA for 20 years. Everybody gets a free coffee cup. Here you go, here you go, here you go.
Yeah, but like really expensive coffee cup. I don't know. It's really weird stuff. But yeah, let's move on.
Okay.
This goes hand in hand with the other one.
Conspiracy fact. Sometimes people turn their nose up at the thought of a conspiracy and think of conspiracy theorists as crazy people. However, keep in mind, a conspiracy is defined as an unlawful, harmful, or evil plan formulated by two or more persons. Plot. By that definition, every police officer should believe in conspiracies, since every bank robbery that consists of a team of two or more individuals qualifies as a conspiracy. Conspiracies are real. Imagine if every police officer thought it was impossible for criminals to work in groups of two or more. Bad guys get caught because of good conspiracy theorists. Our personal and national security depends on the acknowledgement that conspiracies can and do take place.
Okay, so we've got conspiracy theory and conspiracy fact.
Yeah.
You kind of understand the difference between the two?
Yeah, conspiracy fact is like what we already know is true and it is happening. Conspiracy theory is where they find some
Evidence.
evidence that like fingerprints or that they just found something and they're like, it might be happening, but we don't have enough proof to make it a fact that they're doing it.
There's a reason for suspicion.
Yeah.
And so with this one, I always think of the astronauts who died on the Challenger like there's this big explosion and all these astronauts died on the Challenger shuttle, right? And all of a sudden, a lot of them have like twin brothers who look identical to them and even go by the same name. And it's just like, okay.
Really?
Yeah, it's really weird.
I feel like they'd be smarter than that and like hide it up a little more than just, oh yeah, my name is Johnny. Aren't you the one astronaut that died? He's like, no, I'm a different Johnny. He's my brother.
He just looks like him, but it's a brother that has the same name? What?
In 1986, the shuttle Challenger exploded about 74 seconds after takeoff, killing all 7 astronauts inside. Or did it? It turns out that 6 of the 7 are still alive and kicking today. Ellison Onizuka claims to be his identical twin brother, Claude. Yeah, I've got an identical twin brother, Claude, too. The Challenger pilot, Mickey Smith, hasn't even bothered changing his name. He's now Professor Michael J. Smith of University of Wisconsin. Now, Krista McAuliffe was a bit of a sneaky one. She was the Challenger payload specialist, quite famous for being a teacher. It turns out during her astronaut days she was using her middle name, Krista, and now she goes by her first name, Sharon, and she's a Syracuse law professor. The Challenger commander, Francis Richard Scobie, is now Dick Scobie, which sounds like a rather unpleasant disease, CEO of Cows in Trees Limited. Judith Resnick, the Challenger mission specialist, again hasn't even bothered changing her name. She's a professor at Yale Law. And finally, Ronald McNair, another Challenger mission specialist, claims to be his identical twin brother, Carl McNair. What are the odds?
I've always wondered about that. I was like, what if I had like quadruplets when I was older?
Mm-hmm.
Like I was like, what if I get quadruplets when I'm older and I name all of them Katie?
That'd be really weird.
It's like, Katie, time for dinner. They're like, coming.
Yeah, that'd be weird. So,
And then they're like, Katie's at her friend's house. Which one? Katie 1, Katie 2, Katie 3, or Katie 4? I don't know. She's like, oh man.
I can imagine doing that with a middle name. I think it'd get really confusing quick, but yeah, they'd just have fun with it. Yeah.
Well, I don't think it'd be too bad because you would have like a last name too.
Yeah,
Like Adams and Adams and Adams and Adams, but like,
I guess it's true.
but if his
Although
first name would be
women
Barry.
tend to change their last name all the time, though, so that's something
True.
else. But the big important thing here with conspiracy facts is it's the bad guys who don't want people to believe in conspiracy theories, right?
Yeah.
They don't want to be found out. So that's why they talk, oh, only crazy people believe in that stuff. That way
Yeah.
they can get away with it. So,
And that's probably why NASA tries to hide it up about the twins and pretend, oh yeah, that's normal. Everybody does that these days. It's like a trend. Look it up on TikTok, and then they show like this video, and there's like a bunch of kids saying, oh yeah, my name's Billy. My name's Billy too. Billy. I don't. Scientific proof. Believe it or not, in 2006, in the Journal of College Science Teaching, Dr. Jacqueline McLaughlin from Pennsylvania State University reprimanded both teachers and students boldly claiming science never proves anything. She even went so far as to claim words like prove, correct, and true should be removed from our vocabulary completely and immediately. Dr. McLaughlin wasn't alone in the sentiment. Her views were shared by various professors at Haverford College, Forbes magazine, The Scientific American, and Psychology Today. Imagine trying to use that excuse in a court of law where people are supposed to be presumed to be innocent until proven guilty. Your Honor, sorry, science never proves anything, therefore I am innocent. Though the legal system is greatly imperfect, its entire functionality depends on the acknowledgement of scientific proof. With that, a lot rides on exactly how scientific proof is defined.
what do you think of that?
It's crazy that people think that science doesn't prove anything. Like, it sounds crazy. Just like, what's your proof? There is none.
Do you think teachers who don't believe we should use words like correct and true should be grading papers?
Yeah, exactly. I was going to say that, like, they're grading a paper and they're like, okay,
Can't call that
There's
one
that.
correct.
show your proof. We don't teach that at school these days. And they're like, oh, sorry. Do your test and I'll grade them. Grade them. Is there proof that any of it is correct?
If you can't say words like correct and true, do you have any business saying something's wrong?
Or right?
Right? So proof goes both ways. There's both the right way and the wrong way. Right? You can't
Yeah.
prove something wrong unless you know what is actually right. And so,
True. So proof plays a big part in almost anything.
it does. It does. So here we're going to get into those definitions of proof.
In general, proof has multiple definitions, such as the act of testing, which should be a common practice in science. Dr. McLaughlin, however, was more concerned about establishing a thing as true or producing a belief in truth. In this, please keep in mind that acknowledging truths is how people learn. If truth is never acknowledged, then there is no learning that takes place. This is opposite of building on a strong foundation. It is rejecting all foundations everywhere and is choosing to be tossed in the wind of every passing fad and new idea.
It might be true, huh?
Yeah. The scientific definition of evidence greatly narrows things down. A demonstration of truth of a mathematical or logical statement based on axioms and theorems derived from those axioms. In this, it can be scientifically proven that dogs are mammals. This logical statement is based on the axioms of dogs, often having fur, giving live birth, and nourishing their young with milk from their mammary glands. Evidence, on the other hand, can be considered proof if it is strong enough. But in general, it is less certain. It is a reason to believe something might be so, an indication or sign. The girl's head felt warm, which was evidence that she might have a fever. It is an observation that raises suspicion and warrants further investigation. At this stage, it isn't certain if the girl has a fever, but it makes one want to pull out a thermometer to find out for sure.
Yeah. Any thoughts on that?
Like, over here, I guess, where it's like talking about like scientifically proven that dogs are mammals. Like, if we didn't have proof, like, that's like one of the big things about science. So science would like not be established at all, really.
Yeah.
Like, proof is like, oh yeah, we are humans. No, maybe we're dogs, pigs, or birds, or maybe we're just dust with thoughts.
You can tell the difference between. You can tell if a dog is a mammal or a fish.
Yeah, and if we didn't have proof, everything would be so confusing. Like, I would think, if I'm a fish or dust that can think, then maybe couches can think too, and maybe couches aren't actually made because by people. Maybe you can grow them on trees because we have no evidence that people actually make them.
Did you see some political agendas that might be kind of in there for why people might want to toss proof out the window?
Because they're worried about their stuff, that it might not make sense, and there might be like, oh, we sort of don't have proof for this thing, so we're just going to pretend that proof doesn't exist. Okay, everybody, since you believe everything that I say, goldfish aren't actually golden. They're actually like silver. But, so you believe that, right? Okay. So, proof isn't real either, so. With the raise of hands, everyone's crowding and cheering, and yay! Proof doesn't exist anymore.
I feel like there's a whole land of fruits and nuts that are going crazy for that kind of stuff. Right? I'm sure you've heard a lot about that at school with the whole, am I really a boy? Maybe I'm a girl. And there's a lot of drama over that. And that's exactly where I'm talking about this kind of stuff. It's interesting how much politics ends up getting put into our science textbooks.
Yeah, because they put so much like faith in NASA and the government that they're like, okay, we're giving you our money and we're believing whatever you say because we know that the sun gives off heat and we believe that and we know that. So people are also living on the moon, and we believe that monkeys also go up there too.
Yeah. So we used the word axiom again, and you'll notice it's even right there in the definition, the scientific definition of proof. You'll see the word axiom right there, and so it's kind of one of those things that I'm like, I never quite noticed that before.
I think that's one of like the Tesla things. Once they come out with Teslas and you're like, oh yeah, Teslas are everywhere. Then you see them like 5 in each driveway.
Yeah. So an axiom is one of those really basic, obvious things. I've got 5 fingers on my left hand. This is my right, this is my left. Yeah. 5 fingers on my left hand, right? That's an axiom. I was talking to someone about this recently. He's like, no, that's not true. I have 4 fingers and 1 thumb. I'm like,
I don't like when they say that. It's just like,
okay. But thankfully, like, science journals actually acknowledge your thumb as a finger. So
exactly.
Yeah, it can be very much classified as a finger. So that's
as long as they're not counting their toes.
Yeah, but I think
I've got 10 fingers on each. I've got 10 fingers on my right.
Yeah.
10 fingers on my
They're-
left.
I feel like at that point they're just trying to be argumentative,
Yeah.
and they're not trying to find common ground with anyone. They're just trying to split hairs and find whatever little tiny thing they can to disagree with
To
you.
prove you're wrong, exactly.
Yeah, and I feel like that's just kind of, you don't really want to waste all your days with those kind of people. That's kind of like an indicator. All right, let's
Are
move
there
on.
any more pages?
I think the last page was my vocab recap, and that's it. So we don't need to go over that because, yeah, but I like this whole thing because those are the important words, and we kind of continually go back to those words all throughout the chapter, kind of like we did with axiom. We kept going back to that one.
Except it's not really on
And-
there. It's okay though.
Axiom is right there.
Oh,
So,
I was like looking for.
a self-evident truth that requires no proof.
Wait, what's the difference between academic pitfall and just pitfall? Oh, okay, I get it now.
Okay, so the pitfall is like the actual thing, the tiger trap
Yeah.
with the spikes in the bottom and stuff, that were really popular in
Peter
the
Pan,
Vietnam War.
I think.
It's Pokemon. It's really popular in Pokemon. Ash Ketchum continually falls into pitfalls dug by Team Rocket. So, yeah.
I gotta watch that show again. It's funny. It's on
Yeah.
Netflix. We finally got Netflix.
Oh, really? It's on Netflix. Okay, cool.
Yeah.
All right. Thank you. That's been. I will cover chapter 2 next week.
Okay.
Okay. This message has been brought to you by the Flat Earth Institute of Science, powered by Miro. If I've said something that you disagree with, come reach out to me there. Our door is open.